Great. So this is the tutorial on how and where to ask for help when you do Python. Okay. So I'm just going to kind of dive in and, as we go, if you don't understand something or if you're curious about more, please let me know. So there are a lot of different places to start, and I think I can improve this a little bit. But I kind of wanted to start with kind of different forms of where to go to get started with Python. So many of you are getting started here at COESSING, and that's a great place to get started. One piece of advice that I have is finding tutorials online and walking yourself through them. So what I mean by these tutorials is you can Google Python tutorials and you'll get a lot of answers. But sometimes you actually want a little bit more than just Python. Python is used in a lot of different fields in a lot of different ways. It's probably better if you search for scientific Python. That's going to be more related to the science that we are doing. If you want to learn other types of Python, that's great as well. But searching for a specific type of Python is going to be helpful. And more than that, if you know, for instance, what type of data you want to use, so we've been using these terms this week, like tabular data, then it's really great to walk through a tutorial for that specific package, in this case, pandas. So let's just go there. So if I go to pandas now, this is the pandas homepage. You can install it. We don't need to because we already have it installed in our Jupyter Hub. But you can see here that there are all sorts of helpful things. Getting started, you can install pandas. You can do getting started. Let's see what that says. And then it helps you with the installation, an introduction to pandas. So what kind of data does pandas handle? So that's the first question. And then you can say straight to tutorial. You can click there. And then it has this lovely tutorial that you can follow along with. You can scroll down and you can kind of walk yourself through this kind of tutorial. So that's one example. If you don't know what package, you can always Google, or you can ask people here. If you're using a specific method, like if you're doing machine learning, for instance, then you can do tutorials for those packages as well. So kind of based on data, but also based on methods. And so scikit-learn is one of the packages that is used for machine learning in Python. So those are kind of a great place to start. And often, especially the ones that are a little bit more scientific, actually talk through some of the science and the concepts as well as just the coding. Let me see if I can come up with an example. XRFT is one that is a package that's still in development for taking Fourier transforms, which is a kind of advanced form of mathematics, if you're not familiar. But if you go through here, it actually talks a bit about the, so here you can see it has code mixed in, but also has actual formulas. And so it kind of mixes in some of the mathematical and scientific background to the package. So these are really, it's really great to have a kind of a few packages that you know you want to use and to go through those documentation and tutorials. There's someone in the chat. Hello. Good to see you. So here this is just very barely scraping the surface. So there is a resources page, should pull that up, on the COESSING website. Oops, that's not what I wanted to pull up. And I haven't updated that this year, but this resources page has various resources, like for Python and Jupyter Notebook. I have a few things here for learning generic Python. I have some tutorials like Jupyter Notebook for beginners, some videos. So anyway, there are quite a few resources here. So if that works well for all of you, then I'll probably add these as more resources specifically for Python. So these are a few that are quite good that I wanted to highlight. There are a lot of others, and actually I would be very welcome to hear any resources that you all have that you've found out about. So this one, take you there, An Introduction to Earth and Environmental Data Science. This is a Jupyter book. You can see this is what it looks like. This was actually written by my current postdoc advisor for one of his classes at Columbia University. And it has ended up being essentially a textbook for Earth environmental data science. And it's a really useful resource. So this is just the introduction, but we can go Introduction to Jupyter Lab. And you can click here and it will have the Jupyter Lab interface, and it goes through lots of things like this. It has core Python language. It has some scientific Python fundamentals. So we have NumPy and matplotlib. And you'll notice that it has code in line with text. So this is why it's called a Jupyter book. So you have this book, you kind of have these chapters in bold on the side, and then you have little sections underneath those. And so here, that is a very long output. You can see the code, you can have descriptions in between there. And this is all run using a Jupyter notebook as well. So this is a really great resource. You can see what it goes through: scientific Python, data analysis, geoscience packages, and big data. So this is a really, really good one. That's linked here. Project Pythia is another good one. This one is related to the Pangio community, which I mentioned before, which I'll mention shortly. And it's, as they say, an education and training hub for the geoscientific Python community. So the idea of Project Pythia is to consolidate all of the different resources for learning Python for geoscience into one place, because it can be pretty overwhelming when you Google something and you just get lots of results that all look pretty good. So this is their foundations book that they have. This is really ongoing. I think they had a recent meeting a couple months ago that really put in place a lot of what they have here. So they have all these things here, getting started with Python, and they have links. Cartopy, if you want to learn more about the map plotting package, they have information here. So this is really handy for those of us in the geosciences. And as I mentioned, this is part of kind of Pangio. Oh, Zoom is in my way again. Let's see if I can get past that. What is that? What is that? So this is the Pangio homepage. It's a community platform. It's really a community of scientists who are doing geoscience and who are working with data, and especially big data. So this is something I'm very involved in. There are a lot of aspects here that are interesting. I'll talk about the Discourse forum in a moment. But here we have lots of different sites about Pangio, guide for scientists. So this is kind of learning about Pangio software. So it has a discussion here of Xarray and a few other core software. We can also go to the Pangio gallery. So the Pangio gallery is a place where different groups, you can actually add examples yourself. This is all kind of all public, and different groups have added examples in different topics. So for physical oceanography, for instance, if we click here, we can see this list of notebooks that have examples of physical oceanography things. So this is sea surface altimetry. So this is with satellite data. And this has basically an example notebook that you can run. And all of these can run on the Pangio Hub, which I mentioned at the beginning, you will all get access to after this week. But you can also click this button here that says Launch Binder. There's a lot of vocabulary here. So Binder is basically a Jupyter Hub, but it is just meant for educational purposes and not really doing research. So Binder, every time you close your computer or shut down your Binder, it will wipe everything clean. So you can't store any files there. But when you click Launch Binder, it will take you to something that looks exactly like our Jupyter Hub. And then you can actually run these cells on your own. And you can actually make the output yourself instead of just looking at it here. Here you can see a nice interactive plot. Oh, doesn't seem to be changing. Well, it's supposed to be an interactive plot. I'm hearing some noise. Were there any questions? Is it? No. Did you have a question?
Okay. Hello.
Okay, I'm gonna mute that. Yes, hello. Oh, yes.
Okay. So, excuse me. So, are you saying the other online resources are going to be in the new NGO package you want to provide for us?
So I will add all of these resources here and hopefully more to the COESSING website. Was that your question?
Okay. Yes, yes.
Yeah. So this is very difficult.
Thank you.
Yeah, sorry. With the Zoom, it kind of blocks my view. I'll add them here to resources. If this is not a good place to add them to, please let me know. We can try and figure something out. And if you have good resources that you found, feel free to email me or message me on Slack and I'll add them here.
Okay, thank
Does
you.
that answer your question?
Yes, ma'am.
Okay,
Thank
great.
you.
Yes, Paul.
Are you hearing me?
Hello, yes, we can hear you.
You can hear me, okay.
Yes.
I want to find out this number of books you mentioned, can they be gotten on soft copy? Jupyter Lab book.
The Jupyter book.
Pangio and Pangio. Can we have the soft copy on our web page?
By soft copy, do you mean a physical copy? Or do you just...
not physical, just email copy so that we can download and then be able to study properly.
So that is an excellent question. These books are kind of meant to be viewed online. So that's a very good point. Now you can, so up here, you can see there are a few icons. One of them is to download. So I'm just gonna click print PDF and see what happens. My guess is that this will only be the first page. Yep. So this is just the first page. So it looks like if you have a specific page, if you want to learn about NumPy and Matplotlib, you can download this particular page, either as a PDF or as a notebook, actually. But I don't think, let's see. Oh, no, that didn't work. Okay. Oh, that's not showing up. I'm glad you asked that. Looks like that doesn't work on the website, but yeah, I'm also not, I don't know of a way to have this all downloaded, but I will, that is something I'm curious about, and I might try and figure that out. That is a good question. Sorry.
I think we can make do with the websites for all of them so that we can go to the website and have a closer look at them, because sometimes the screen, we're looking at the screen, some of the time Paige, some very tiny, we may not be able to follow most of the things right now.
Oh no, sorry, I can zoom in. But anyway, most of this is just to show you that it exists, and then you can read it yourself. But yes, I think this is one where you will want to click this link and kind of view it through your browser. This is a good question.
Thank you.
Any other questions while we are stopped? Okay. So another place to look for help is package-specific documentation. So I mentioned this kind of before. If we go to the Pandas website again, keep closing these so I can access these tabs. You can see here documentation. So this is one, if you know you're using Pandas because you're like, I'm using tabular data, I want to use Pandas, but I'm not really sure where to start. You can click on this user guide and it will take you here. and it has every package is different. It depends who writes it, but it has this really nice 10 minutes to pandas. So if you click on that, it kind of says, 10-minute introduction to pandas, which is pretty handy. There are also all sorts of other things, introduction to the different data structures that pandas has, and so on. There actually is a huge, giant list. So there's a lot to learn. So this is kind of considered documentation. So you can, look at, let's look at plotting. That's something we all do. And now you can see kind of an introduction of here's how you might do some plotting with pandas. Oh yeah, so another interesting aspect of documentation to note is what's called the API reference. So if I click there, I have this here. I already forgot what it was called. API is Application Programming Interface. So the API is really helpful if you know the function that you want to use. So you don't need to kind of start with the general knowledge. You like, yep, I know what function, but I forget what inputs it takes. Or something like that, where you just can't quite remember how that works. Then you can go to the API and you can click something here. Let's do plotting again for consistency. And now we see a list of the different plotting options through pandas. So .plot is something that we've seen in our tutorials. So we can click on that. And this tells you that we can input arguments and these keyword arguments. That's what quargs means. So here it says parameters, so inputs. By parameters here, in this case, they mean inputs. So we'd input a data set, which can be of a series or a data frame type. We can have an X label or position, a Y label or position, and then you can have kind. So you can write if you're doing a line plot or a bar plot or a histogram. So anyway, I won't go into the details of what these all mean, but this is the API is really helpful, because I often don't quite remember how, I say .plot. Wait, I wanted to make a histogram. I forget how to do that. I can just go to the API, say, oh yeah, hist, that's how I'm going to get my histogram. So that's a really useful tool. Okay. So now we're going to move on to some error messages, which is just something I think is worth noting. So we'll kind of go through this quickly. Error messages sometimes can be a little startling, or you get an error, you're like, oh no, I did something wrong. That is fine. That's how we roll. If you're running a really, really big computation, then maybe you don't, maybe you want to make sure there aren't errors beforehand by running a smaller example. But if you're just running a line or two of code, like here, maybe I'm just typing quickly, and I just type import nump as an NP. What I meant to write was numpy, but I made a typo. So let's evaluate that. And then we get this module not found error. So that's pretty self-explanatory already. It says the module is not found. And then it even specifically says there's no module named nump. And so I'm familiar with this, and I would look at this and be like, oh, right, I just typed it wrong. If I add a Y, then it'll run fine. So that's just an example of, interpreting an error message and correcting your mistake. Let's see a few other different types of error messages. So here, I am purposefully mistyped the word a range, which is a function of NumPy that creates an array. So what I wanted is a to be an array of size 10. So if I do this, we see it's actually a different error name. It says attribute error. And this says module NumPy has no attribute a range. So again, this, if you don't know what this means, it's reasonably self-explanatory. And I can just now say, oh, right, I meant to say a range, just fix my typo, and then I can run it here. So another type of error is maybe I use the wrong type of parentheses. So if I do this and say a of 4, this is now a type error because it has the wrong kind of type of syntax. This says numpy.ndArray object is not callable. So I know what this means because I've seen this error a lot when I do make a mistake. But if you're newer to Python, this might be a little harder to know. What does that mean? So you know what I can do is I'm going to copy that, open up a tab, and we can just Google that error and see what we find. And so, yeah, so in this case, we don't even need to click on a website. Google has pulled up this nice sentence for us. It says, this occurs when we try to call an array as if it were a function. To solve the error, make sure you use square brackets when accessing an array element. So that's what I actually meant to do. I created A, and then I wanted to print the fourth value of A. But these rounded brackets in Python refer to a function, whereas I wanted to actually access a value, which means I need to replace these with square brackets, and then it prints it out nicely. Oh, I guess I had that below. We didn't have to rewrite this. So I was just going to point out one more thing. When we do have this error, we can see it actually has this arrow pointing to the line that caused the error. So here I have two separate lines. And if it just said type error this, I might not know which line it's talking about, but the error messages are very helpful usually. And it says, you know what, the error is on this line. So that's important to note, how to read an error message. Okay, so I'm going to do one more, just show another error message for you. And this one will look a little bit more startling. It's a longer one. So now we have an attribute error. And you start scrolling down and go, oh my gosh, this is such a long error. Most of the errors that you will get in Python, like this, the first thing you want to look at is the bottom line. So the bottom line is what tells you what the final error message is. So this saying attribute error, line 2D object has no property title. Again, that might be a little cryptic. Line 2D is a little weird because I never actually called that. I just said dot plot. But since I have some familiarity, I actually know that when I call dot plot on a one-dimensional thing, it's going to use this line 2D plot method. And so when it says has no property title, I can look back and say, oh, whoops, I can't make a title like this. This is not how I create a title for my plot. And again, if you look at the very top, it has that arrow pointing to the line that's causing the trouble. Now, all of these other lines, you can sometimes just ignore. Me seeing this error right now, I would ignore them because I can interpret the error. Usually you will want to ignore these. Sometimes you might want to go into more detail. And then these actually say in this specific file. So this here shows you that this is in a Conda environment. So this is like when you're downloading Anaconda, we're using a Conda environment on the cloud. Conda /environment/notebook/ blah, 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 /matplotlib /pyplot.py. So this is actually telling you the exact file in the pyplot package that's causing the error to occur. So if you are developing the package, or if you're really trying to get into the nitty gritty, you can go to this pyplot.py file at this path, and you can go to line 2769, so it tells you the line, and you will see this line here. So you has this arrow at 2769, and it says this is the one that was causing the problem. Now, there are a lot more of these because a lot of these packages kind of depend on each other. So here you can see this is an axes.py, there's a base.py, there are a few others. So it does get a little bit complicated. So normally you can ignore that, but that's maybe more information than you needed to know about how to read these error messages. So the error messages are usually very helpful, but sometimes, especially if you're new, they might not be understandable, in which case we can use Google. And Daniel has stressed this, but Google is our friend, usually. Any questions about those error messages? No questions? All right, I'm just muting if you are not asking a question, so I don't get feedback. but please unmute to ask any questions or say any comments. Okay. I'm not hearing anything, so I will keep going. So I mentioned before that you can go to documentation, like we went to the pandas documentation. There's actually, Jupyter has a nice feature. If I start typing, let's say I want to do this np.arange function again. Actually, I just want to, if you're not familiar with it, if I'm saying a equals np.arange of 10, then I print a. This gives me an array from 0 to 9, which is 10 values. So that's what I want to do. But let's say I forget what the function is. I remember it's a range or something like that. And I say, oh, it starts with AR. I can type tab on my keyboard, and it comes up with all of the possibilities that start with AR. So I can, scroll down here. So this is a really nice, you can see arange is actually the first one, and it says it's a function. There are a few other options that we could have. As I keep typing, it will just keep narrowing this down. So you can actually, if you do np dot and then tab, it'll show you all of the possibilities, but there are zillions and zillions. But this is just really nice. If you're like, oh, let's see, it was a something, a range, great, that's what I wanted, and then you can continue. So that's great to know. There's also, if you remember the name of the packet or the name of the function that you want to use, like arange, but you forget again what the inputs are or what the outputs are, then you can type this question mark and then evaluate the cell, so shift return, and this gives you what's called the doc string, which is actually the same thing that you will find in the documentation's API that I mentioned before. So this tells us arange is a function. The first input is start, stop, and so on. It tells you what it is. It returns evenly spaced values within a given interval. And then it has the parameters. So it says you can input start, which should be an integer or a real number. It also says that's an optional input. Stop is not optional, so you have to provide that. So anyway, it gives you all of that useful information. It tells you what it returns. It says it'll return an n-dimensional array. It has some warnings here. That's quite interesting. So anyway, this is a nice way if you don't want to have to go into another tab and search for documentation for numpy.arange. You can just do it here within your Jupyter notebook. Okay.
Hello.
Oh yeah. Yes. Hello.
Okay. Please, can we do this in also in Panda?
Yes, you would be able to do this with pandas. Yep. Good question.
Oh.
So let's go ahead and try that. So you first have to import the package. So I'm going to import as PD, import pandas, and then I can say PD dot tab, and it opens up all of the options. So if it's is it load data set? Nope, it's read. There we go. So read CSV. So there we go. I actually just used this because I couldn't remember whether it was load CSV or read CSV. Typed load, it didn't come up. I type read, I can see, okay, I want read CSV, and then you can, keep typing.
Thank you.
Yeah. Were there other questions? Okay. Then I will move on to kind of where to ask for help. So this is all of that I've talked about so far is how you can help yourself. Sometimes you get to a point where you can't find a Google answer. You're just not sure how this works. So there are a few places that you can go to ask questions. I guess, first of all, especially for this school, you can use our Slack channel. That's what the Python 2022 Slack channel is for. So that's open to all of you. Stack Overflow is a really great resource. If you've Googled any errors, you've probably come across it. This is kind of what it looks like. Let's see if we can find some tags. Let's go to Python. And then you can see people asking questions. How to create a new column in data frame based on substrings from another columns using NumPy. So this is someone who has asked a question. They asked it today. There are no answers yet, but this is a nice community forum where you can ask a question. You can also answer questions. So if you see this, you're like, oh, I know the answer, I can help this person. You can sign up and you can write an answer. So Stack Overflow is one that I find all the time when I'm Googling, and that's, it is hit or miss because it's anyone on a public forum posting questions, but you can often have maintainers of packages answering your questions. So that's a good one. The Pangio Discourse forum is another one. So this is part of that Pangio community that I mentioned. So this is the Discourse forum. This is a place where we can, it actually is kind of where the community communicates with each other on many different topics. So you can actually see that there's a tag here for jobs. There are a lot of kind of science related software jobs that get posted here. So if that's something you're interested in, you can follow along. You can see these different different tags. So this one is for cloud. So if someone had a question about writing large data sets to TIFF files, and they've just posted that. Looks like no one has responded. So again, you're a little dependent on people responding to these, and I'll have a little bit more to say about this later. This is a tag for data. So I feel like, oh, I don't know how to use this data on Pangio. So, and here there's a bit of a discussion, and you can read that. Oops, some nice visualizations as well. So this is a place where you can ask some questions. We have different categories and tags. So you just want to make sure that you use the right tag that will get you a response quicker. And this is an especially useful resource if you do log on and start using the Pangio hub. Then you can use this as a way to ask questions about how do I do this on the hub, or can we get a new package added to the hub, and that kind of thing. There's a tag for that. I forget what it is offhand. Maybe it is just cloud. So anyway, it's a nice community. And if you're in the geoscience space and want to do more computing, I encourage you to get involved. So that's the Pangio Discourse forum. There are also Github Sites. So what I mean by that is like GitHub is a website, and we'll be going into that in a few minutes in more detail. Sometimes when you Google an error, you'll come up with a GitHub site. Often it's an issue, a GitHub issue, which again I'll show in a moment. And these are where there's actually a bug or some problem with a software package. You or someone can start an issue and that say, I tried to do this, but it gave me a strange error, and I think this is a bug with the code, as opposed to me doing something wrong. So sometimes you might come across those issues. Sometimes they're still, it means code is still in development. Sometimes there are good answers in the thread. It's kind of like a community forum kind of thing where there's like a thread of answers. There's also something called GitHub Discussions. Dask has this, so I'll open that. This is a GitHub website. So this is where the code, this is Dask/distributed. So this is the distributed package. It's part of Dask. This is the actual code base for Dask distributed. It's fully open source, so you can read it all. Here are all of the issues. It has almost 1,000 issues. It's a very heavily used package, so it gets a lot of action. So here are some issues. You can see there are some tags here that kind of help. And so anyway, you can see here, people will, sometimes there's a discussion of, I don't think that this should be a feature of this package. Sometimes there are bug reports. So if you go back to the discussions tab, this is where Dask, people can ask questions of Dask, and you can upvote them. Let's see if there's some that have been answered. Is there a way to define a worker resource as infinite? I don't actually know what that means, but here we go. Someone asked this question. It was answered. And I think the actual person who asked the question can say, yes, this has been answered. So this is another community forum to ask questions. So I know Dask has this discussions tab. Not all packages do, but it's at least something to explore. So here's a little flowchart that someone I worked with in Australia actually made. This was specifically for the Oceania region, so that's like Australia and New Zealand. So there are a couple things here that aren't relevant, but for the most part, this holds up. And so basically, if you have an issue and you come across an error, you try Googling it, you try to understand it, and you're like, oh, I just don't get it. You can say, has anyone encountered my problem before? That's where you Google and you say, you know what, it did look like people have had this problem before. Then there's this question of, was the problem resolved? If it was, then great, you're good to go. You can move on. If not, if you're seeing people ask the question, but no one has answered them, then you can contribute to an existing discussion. So you can say, you know what, I'm having the same problem. Here's another example of it. And it might get some of the community members and software developers to actually notice and say, oh, we've had a few people with this issue. We should really get to it. So if you don't know if anyone has encountered your problem before, then you can come here and say, is my problem related to a specific tool or platform? This is kind of what I was mentioning before. If you know it's something to do with Xarray or Jupyter. If yes, is the solution to my problem likely to result in changes to the code? So do you think you found a bug, or are you just confused and don't know, what's going on? If you think you found a bug or you have a suggestion for a new feature, that's where you can start a GitHub issue. If it's not, if you're just like, no, there's just a problem that I'm having, I just don't know how to solve it. Here are some of the things that I was just mentioning. There's Xarray discussions. So Xarray is like Dask, also has these discussions. There's a Jupyter Discourse. There's a Dask Slack workspace. You can open up a GitHub issue for this, Stack Overflow, and then the last one here is Pangio Oceania meetings. So we're not in Oceania, so you're not going to want to go to those probably just from the time zone. But Pangio does have regular meetings, and I think the Pangio Discourse is a really great place to start. I think I saw a question in the chat, just to know, is it possible to run Jupyter Notebook offline? Okay, that's a good question. It depends what you mean. Yes, it is possible to run Jupyter Notebook offline. If you have installed Anaconda on your own computer and you are wanting to just run Jupyter on your own computer, then when you type Jupyter Notebook, you open up a Jupyter Notebook, all of that is offline. So you have to be online to download Anaconda. But then once you install it, you can run Jupyter Notebook, and that all runs locally. Even though it's opening a browser, it's still running locally. If you want to use something like this Jupyter Hub that we're on now, that one you have to have internet. So it runs on internet, but it doesn't require high bandwidth internet. And while we're on that topic, I'm actually very curious to know how the Jupyter Hub is working for you with your internet connections. So if you're willing to provide feedback, I'd be really grateful for that. And we can, try and make sure that we make this an easy process for all of you. So this is a nice little flowchart to follow. There are a few kind of caveats down here. What I'm going to mention here very briefly is how to ask for help. So I've been saying things like post on the Pangio Discourse or post a GitHub issue. When you do that, it's best to think a little bit about how you are asking your question. This is really important for a couple reasons. First of all, if you just say, I can't figure this out, and you don't provide any extra information, no one can help you. We don't know what the problem is. If you just say you're having a problem, we have no context to help you. So this is what I was saying last week and earlier this week. When you have a problem, being specific, saying, I am able to open my Jupyter notebook, but then I can't load a package. You know, like you can say what has worked and where the problem occurred. You can send a screenshot. That's really helpful. And even more than all of that, it's really great to learn how to write a minimal, complete, verifiable example. Oops, I have a typo there. Or equivalently, they're just two different names for this, a minimal reproducible example. So I have this link here of how to write one. Notice it's at Stack Overflow. This is a really great overview of what this means. So it says minimal, use as little code as possible. That still produces the same problem. Complete, provide all parts that someone might need to run this code. So if you have to import a package, import that package, include that line. Otherwise, someone tries to rerun it and they're just getting different errors. And reproducible. You want to test that the code does reproduce the problem and it didn't just happen once. So these are really, really important. This might not sound, very difficult or interesting, but it actually is very important. And for all of the reasons I just said, so that you can get help, but also you are much more likely to get an answer if you provide as much detail as possible. A lot of people in these community forums are responding to a lot of help questions, and a lot of software developers have a lot going on and they want to help you. But if you don't give enough details where they can reproduce your example and figure out what the error is, then they may not even take the time to ask you for that, because that takes a lot of time to each person. If someone hasn't included the right, included all of the code, it takes a lot of time to say, hi, thanks for your question, please include all of the code. So they might not even do that, and you might not get your question answered, or at least not as quickly. Whereas if you provide as much information as you possibly can and keep it minimal, that's the other thing, instead of copying 50 lines of code for one line that breaks, you are much more likely to get a quick response. So I think that's a really, really important aspect of asking for help. And this does take a little bit of time. I personally find when I have a problem like, oh, this might be a bug, or I need to post this somewhere, by the process of making a minimal reproducible example, I kind of go back here and remind myself what that is. Half of the time, I then figure out my problem because I'm reducing it down, and then I say, oh, wait a minute, now I know what's wrong. So this is a really, really crucial step. Okay. So that was a lot of me just talking at you about tips. Are there any questions about any of this? And I'm asking for questions about how to ask questions, but if there are any questions, please ask them now. Paul, yes.
Are you hearing me?
Mm-hmm.
Yeah. Will I be correct to say that Python, Pangio, and the other one you mentioned are programmable programming languages? And if you are using if you have any issue that you desire response, you ask questions to them on the Anaconda page also, and then it will give you probable answers from one place or the other relating to your question.
Yes, that's I think the idea is right. Pangio is a community. It is a community for Python geoscience users. So Python is the only computer language that we're talking about here. But we have these different packages. So Pangio is not a package. It's a community of people. But you do have these packages like scikit-learn, like pandas, xarray, Dask, several like that. And that's where, if you need help with those specific ones, it's good to go to those websites. Or Pangio kind of covers all of the geoscience related packages. That's kind of a catch-all community for any of these geoscience packages.
Okay, but Python, is it Python? Can you use it like when you're like COBOL, when you're using COBOL, COBOL and Fortran languages. Is it similar to the Python programming?
Yes, so they're all programming languages. They have their differences. Fortran is an older language. It's one where you have to compile it beforehand, and it's not as easy to use or to learn. But Python is basically an equivalent language. A lot of climate and ocean models are written in Fortran still because it's very fast, but most people who do analysis of the data from those models use Python. But more and more people are using Python to actually write the models as well. So, yeah, Fortran is another. There are other computing languages, and Python is another option, as is R or Julia.
But from what you're saying, Python tends to be more modern and more accurate in terms of giving reliable programming programs.
Yeah, I don't know if more reliable is quite correct. Fortran's a fine language and other languages. Python has a few. I actually talked about this in my pre-workshop last week of why we're using Python. It's relatively easy to use and to learn, so that's really nice. And the other big advantage is that it is very widely used, which means you have a very big community of people who can help you and who have probably come across your problem before and fixed it. So for all of those reasons, it's been a very useful language to teach and to use.
Okay, thank you very much.
Did I see another question pop up while we were chatting? Nope. Okay. So let's see if I can figure this out. I'm going to